Okay, question 1. Agatha and Bryn each bought some pens. Each pen Agatha bought was £2.20, each pen Bryn bought was £1.40. Altogether, the cost of the pens was £13. How many pens did they buy altogether? Right, so what I've done on the left-hand side is I've written down all the multiples of £2.20. Okay, this is Agatha's pens, so I've gone up from £2.20 and kept adding on until I get to this down here, okay, which is £13.20. We know we're not going to go that far because we know the total cost of both pens is £13. I've done the same for Bryn's pens, and I've gone all the way up to £14. We know down here that that is more than £13, so that can't be in our combination. Next, I've decided to just sort of try an improvement, really, just try and add these two, one number up from here to another number up here. And what I've done, I did the green ones first, £4.40 and £5.60. Okay, that gives me a total of £10. That's not correct. I tried again here, £6.60 and £8.40. That gives me £15. Then I went down to this one here, £8.80 and £4.20. If you add those two together, you're going to get yourself £13. So altogether, Bryn and Agatha spent £13 and 4 pens from Agatha and 3 from Bryn. So there's a 7 total, 4 and 3. Okay, question 2. Calculate the size of an interior angle in a regular 12-sided polygon. What you need to realise is how to calculate the sum of interior angles. This is done by taking the number of sides, minus 2, then you times by 180. Can you realise that I have put the brackets in here first? So you do the number of sides, take away 2, then you multiply that by 180. So we've got 12, take away 2, which is 10. 10 times 180, which gives me the total sum of interior angles in a 12-sided polygon to be 1,800. Okay? If we divide that by 12, because we're looking for just one interior angle, that gives us an answer 152 degrees. Part 2. Do regular 12-sided polygons tessellate? You must give a reason for your answer. No, they do not tessellate because 150 is not a factor of 360. So if you try multiples of 150, 2 lots of 150 gives you 300, and 3 lots of 150 gives you 400. The one's not enough and one's too much. They won't fit perfectly together, hence they won't tessellate. Okay, simplifying each of the following. What I've done here, I've squared off the like terms, which are the g's here, and then circled the h's. Okay, really important we take into account the signs in front of these terms. So we got minus 7g minus 6g, so that gives us minus 13g. And here also we have minus 4h, but here we have two minuses next to each other which become a plus. So we're actually going to have minus 4h plus 8h, which would give us 4h total. So it's minus 13g plus 4h. Part 2. 3p to the power of 6 times 5p to the power of 5. I've underlined the coefficients and numbers in front of p first of all, because that's what I'm going to do first. 3 times 5, which is 15. Then I'm going to look at p's and the powers. They have the same base, so what we're going to do to the indices, what we're going to do to the powers, we add them. So that becomes 6 add 5, so it's p to the power of 11. Part 3. Same goes here. I'm doing the numbers first, so I'm doing 46 divided by 23, which gives me 2. Then I'm going to take y divided by y to the power of 6 divided by y to the power of 2. When we're dividing with the same base, we subtract the powers, so it becomes y to the power of 4. Part B. Pencils cost x pence each. Pens cost twice as much as pencils. Write and simplify an expression in terms of x for the total cost of 3 pencils and 4 pens. So all I've done is some basic highlighting here just to break down the question. So in yellow I've got the pencils cost x pence, and I've got 3 of them. So in yellow here, if you can see, I've got 3 lots of x. I'm then told that the pens cost twice as much. So instead of having x, I've now got 2x. So the pens cost 2x. I've got 4 lots of those pens, so I'm doing 4 times x. So I'm left with, underneath, 3x plus 8 lots of x, which gives me 11x. So my simplified expression would be 11x. Okay, this first part is a lot of information. There's only 2 marks. So what I've done, again, I've highlighted the key bits from these bullet points that were given to you. It says 1 centimetre more was rained on Sunday, Monday and Tuesday, 1 centimetre less on Wednesday, Thursday and Friday, and the same amount on Saturday. It's asking for what was the mean daily rainfall in the second week. So in the first week it was 3.8. You want to compare it to the second week now and give a reason for your answer. So what I've done, I've written down the 7 days of the week and how much they've changed. So on the Monday, Tuesday and Sunday there was 1 centimetre more of rain, and on the Wednesday, Thursday and Friday there's 1 centimetre less. On the Saturday it didn't change at all. So the plus ones and the minus ones will cancel each other out. So this is going to give us the same mean. So we've got plus 1, plus 1, plus 1, which is plus 3, minus 1, minus 1, minus 1. They will cancel out, so the mean will still be 3.8 centimetres. Okay, across to part B. This is asking you to find an estimate for the mean. First mark you'll get for showing your midpoints. So this column here, create an extra column here, 1, 2 and 3 and 4. Okay? You need to find the middle of these groups. You can do that by adding them up and dividing by 2 if you're unsure. After you do this, your second mark is from multiplying across to get midpoint times frequency. So you're multiplying all these numbers here, so midpoint here 1 by the number of days, which is 5, to give your answer 5. 2 times 11, which gives you 22, and so on. And that second mark is going to come from totaling those 2 up, or those 4 up to make 70. Your third mark then comes from estimating your mean by taking your total frequency times midpoint divided by your total frequency there, which is 70 divided by 30. Now if you realise here, that has been shaded out. You don't need to find the sum of the midpoints, just the sum of the midpoint times frequency and the sum of the frequency. Your fourth and final mark then is for getting your answer of 2.3 recurring. Okay, 2.3 recurring. Part 2, state the modal class. Modal means the most common. So the most common up here is going to be the group with the highest frequency, which is 2.5 to 3.5, because it has 13, the highest frequency. Part 2, write down the class interval which the median lies. So there are 30 people total. So there's the frequency is 30. So halfway would be 15. You want to find where that 15th value lies. If you've got 5 in the first group and you've got another 11 in the second group, that gives you a total of 16. So that by the time you got to the second group, your median is going to be in this range here, 1.5 to 2.5.
Okay, and this question was actually classed as a C grade question. It's also in the foundation, but I did feel it was a very, very hard C grade question. There's an awful lot of information going on there. With currency exchange, we're used to seeing just going to 2 decimal places, and then most of these are going to 4 or 5 or maybe even 6 decimal places. It's very important that you do read what the information says before you try tackling this question. So it says an internet company offering money exchange displays a conversion table as shown below. The method of using this table exchange is as follows. To exchange GB pounds to euros, read down the table, £1 is 1.1116 euros. Using the exchange rates from the table, calculate the following. Exchange 200 US dollars to Australian dollars. So because I'm exchanging US dollars, I need to be on the US dollars here, and I'm looking for Australian dollars here, so I'm following down the table until I meet Australian dollars, which is this bit here. That has enabled me to write down this conversion. $1 is equal to 1.09137 Australian dollars. So that means that I must have multiplied this one by that number to turn it into this. So 1 times 1.09137 would turn it into 1.09137. To turn it back into 1, any number divided by itself is always 1. So that's telling me to change from US dollars to Australian dollars, I must follow the top arrow. So that meant I need to do the calculation 200 multiplied by 1.09137, which gave me this number here, which as it's money must always be rounded to 2 decimal places as your final answer. The next question said how many Canadian dollars were exchanged to give 250 euros. So coming back to my table, because I was on Canadian dollars, I wanted to find euros and match those two up to get this value here. So that meant that 1 Canadian dollar was equal to 0.676175 euros, which meant I was multiplying going this way, dividing going back. And this time, it said 250 euros. So I'm on the euros, I need to get back to the Canadian dollars. That meant I needed to divide by 0.676125. That gave me an answer of 369.72677719, which again must be rounded correctly to 2 decimal places. For part 2, it asks you to work out the missing conversions. Now I know from my table, Hong Kong dollars into euros, 1 Hong Kong dollar would be equal to 0.090147 euros. So I've written that down by here. And using the same technique again, I've said to change 1 to that number, I multiply by this number, and to change this number back to 1, I divide by this number. So that tells me to change dollars into euros, I multiply, and to change euros into dollars, I divide. So the next calculation I've done is 1 euro divided by 0.090147 to turn it into Hong Kong dollars. That gave me this answer here. Now looking back at the table with so many decimal places, I decided to keep my answer exactly as it was and didn't even bother to round it. As long as you did round it correctly to about 4 or 5 decimal places, you would still get full marks for that. For the other bit, I knew that 1 euro was equal to 133.5 yen. So that meant I was multiplying going this way, dividing going this way. So to work out how much yen was in euros, which was my missing one here, 1 yen equals how many euros, I need to do 1 divided by the 133.5, which gave me an answer of 0.0074906. Now that did go on a little bit further, but I felt that was so many decimal places, I decided to round it to 7 decimal places.
Okay, solve x over 3 plus 42 is equal to 53. Solve basically means just find out x. What is that x value going to be? Now the most common misconception here is just to get rid of this 3 down here straight away and multiply it by the right hand side, 53, and forget to times it by the 42. I'm not going to do that first. I'm going to get rid of the 42, so I'm going to subtract 42, but whatever I do to the left hand side, I must do to the right hand side as well. So on the left hand side I'm left with x over 3, on the right hand side I'm doing 53 minus 42, which gives me 11. Last step I need to do, I don't like this 3 down here, so I'm going to multiply by 3. So I'm going to be left with x is equal to 33. Part B. Again, we've got a denominator down here which we don't like. We want to get rid of that, because ultimately we want to find out what x is. So we're going to get rid of this denominator, so we times everything, both sides, by 11. So we're left on the left hand side now with 40 minus x. 4 times 11 then is 44. So 40 minus a number is equal to 44. So I want to get rid of that 40 on the left hand side, so I'm going to subtract 40 from both sides. That leaves me with minus x is equal to 4. Hence x is equal to minus 4.
Okay then, in this question here, you're asked to use, or you're going to use a method of trial and improvement. It tells you that the solution lies between 1.2 and 1.3, and I'd always recommend that you do substitute those numbers in that they give you, because you will get 1 mark just for subbing in 1.2 and 1.3. So if you've already done that, you can give yourself a mark. In this table here, we've skipped that step and gone in between 1.2 and 1.3, which is bang in the middle as 1.25. When that answer was subbed in, so we treated x as 1.25, so you're doing 3 times 1.25 cubed minus 1.25. That answer is coming out at 4.609. Now the answer we're supposed to get is 4.5, so that answer is too big. So the next thing we've done is we've tried 1.24, we've gone down. If this answer is too big, then it makes sense to go down, but I would always recommend that you go down only in consecutive numbers here, so don't start skipping values and going to like 3, 2, just go in the counting numbers. Now that answer was 4.479. We're supposed to get 4.5, so that is too small. So that is where you get your second mark, as it's gone too big, too small, in consecutive numbers. Okay? Now whenever it says 2 decimal places or 1 decimal place, you must go one more than what the question said to check. They're looking for you to do that for your accuracy. So because we said it's in between these two numbers here, you come to the lower number and you put a 5 on the end to go bang in the middle between these two numbers. That answer came out at 4.544, which is too big. So as soon as we did that, we got our third mark. So that was our second mark, and subbing in those was our first mark. So what we found was this solution was too small, this solution was too big, so we said it's got to be in between these somewhere. We've tried bang in the middle at 1.245. That solution is too big, so that's telling me it's between these two numbers, hence it is going to be closer to this answer to 2 decimal places. So you should then make the choice of 1.24 to 2 decimal places to get your fourth and final mark. Okay then, so the most important statement for me is this first statement here. The total surface area of one cube is 54 centimeters squared. Okay, so the first thing I did was I wrote down, or I drew down, a picture of a net of a cube. And because I don't know what the area of one of the squares is, I've called it x, but because it's a cube, it means that every single area must be the same. So I've called all of them x. Okay, now it's a bit of a common misconception that QWC means you have to write an essay. You don't have to write an essay. You can just write down and draw down little diagrams like this and then be writing things by the side of it to explain what you're doing. You don't need to write down an essay. However, I'm not saying that's not a good idea as well. So I've said what this is. So I'm just explaining to an examiner who's marking my work, look, this is the net of this cube. Okay? So my first line of working here then has said that 6x's, because there's 6 squares, comes to 54. And as you can see, I've explained what I'm doing here. What is 6x? There were 6 squares in total, so that's why I've got 6x. Why have I got 54? Because that's what the total area was. Okay? So what I've done then is I've divided each side by 6. So I've taken the 6 over to the other side and divided by the 6 there, whichever way your maths teacher has taught you, to get x equals 9. And I've said here, so the square is equal to 9. And if you notice here, I've written centimeters squared. It is very, very important in QWC questions you write down your units. So whether that's centimeters squared, centimeters cubed, or pound signs. Next, I've done 18 times by 9. And you might spot how I worked out there's 18 up by here. I counted the obvious 9 there that I could see. I know that each one of these squares is worth 9. But I'm also aware you're going to have a square on the back and a square on the bottom as well, including the 2 sides. So I've counted up all of those together and I got 18. And again, I've described where that 18 has come from. 18 squares in total that are visible. Finally, I've multiplied that by 9 because the area of one square is 9, and that gave me 162 centimeters squared. If you got 172 centimeters squared, you get 4 marks straight away. If you've got clear maths that is showing everything that you're doing, you get 1 of the QWC marks. And if you've described what you've done and how you've done it, then you will have got your second mark, just like I did. Okay, so just looking at the question, it's important that you highlight things that are important in the question. The first thing that I spotted was it's a profit of 26%. Obviously, the £120 is really important as well. So she bought this jacket for £120, made a profit of £26 by selling it at an auction. How much did she sell the jacket for at the auction? So the first thing I've done is I've worked out what 26%, so 26 out of 100 is of 120. And you do that by doing 26 divided by 100 times by 120. That gave an answer of £31.20. That will get you 2 of the marks out of the 3 that you've got there. So to get your third and final mark, you needed to have your original price and you needed to add on your selling price. So 120 add the £31.20 gave a total of £151.20. But it's a very common mistake that people accidentally forget to put in this green bit of writing here. Don't forget that it's asking you how much it was sold for. For the second part, it said, given that 65% of a measurement is 43.55 metres, calculate the whole measurement. This is a firm B grade question. This is something called reverse percentages. Quite acceptable to have struggled with this one. So I've written down here what we knew. We're told that 65% is equal to 43.55. I don't want to know what 65% is. I want to know the whole measurement, and the whole measurement we could think of as 100%. So I'm thinking now, how do I try and change 65 into 100%? How do I change 65 to 100? Well, the way I do it is I divide that number by itself. So a little bit like we looked at earlier with the exchange rates. Anything divided by itself is 1. But whatever you do to one side, you must do to the other. So I've put into my calculator 43.55 divided by 65, and that has given me 0.67, which is a very small number, but this is now 1% of that original measurement. To find the original measurement, I need to times by 100, because 1 times 100 is 100%, and whatever I do to one side, I must do to the other side. Okay, then, so this was drawing graphs bounded to make a region. Whenever you see these inequality signs, you want to think of these as equal to signs, and we'll worry about the inequality when we start shading on the graph. The first graph can be thought as either something that's really, really tricky or very, very easy. It says x plus y must equal 4. So if I'm thinking of pairs of numbers that add together to equal 4, I could find coordinates 1 and 3, because 1 add 3 equals 4. I could plot 2 and 2, because 2 add 2 equals 4. Or I could plot 0 add 4, because that still equals 4. If I go and plot those 3 coordinates, I'd then draw a straight line through those points. The alternative way is to rearrange your graph in the form y equals. Okay, so getting y on its own, so this x would be coming over to the other side to become minus x. And then you choose any at least 3 coordinates, but Sir's done 5. As long as you have 3, that's fine, so you can draw a straight line through those points. The second graph was already in the form y equals mx plus c, so we needed to draw an xy table. So x values again, minus 4, minus 2, 0, 2 and 4, but you can use any values there. You could use 1, 2 and 3, you could use 0, 1 and 2, it really doesn't matter as long as they're values that you can then plot on your graph. And then you substitute your x value, so if I had this x value here, 4, I'm told that y is equal to 2 lots of x, add 4, so 2 lots of minus 4 would give me minus 8, but then adding 4 to that would give me minus 4. And then similarly here, if I chose the 2 lots of x, so 2 lots of 2 would give me 4, add this 4 would give me 8. So that's how Sir got those values. You then go and plot those on the graph and draw your straight line through it. The final graph, number 3, was the easiest one to draw, and I saw a number of people drawing that first, which was really, really good. The graph of y equals 1 is a straight line that goes through the value of 1 on the y-axis. So this is what your graphs should have looked like by the time you plotted them. It's important that you label what each graph is. So this line going through the y-axis at 1 is y is equal to 1. Now the fact that we wanted y is greater than or equal to 1 meant that I didn't want this bit of the graph here, so that's why it's been shaded out. I didn't want that bit, I want everything above because I'm told that it's got to be greater than 1. The first graph, x plus y is equal to 4, is the green line that comes through here, and as you can see, there's my 4, 0, there's my 2, 2, there's my 3, 1, they're all on that line. Now I was told that had to be less than or equal to 4. So if you're unsure of which side of the line that you have to shade, pick a point on this line. I always pick the origin. So the origin has coordinates x equals 0, y equals 0. If I substitute these values in, I can work out whether this point is on the right side of the line that I'd like. So that would be 0 plus 0, which is 0, is less than or equal to 4. Is that true? Yes, it is. 0 is less than or equal to 4. It's less than 4. So that meant that my origin, this point here, is the side of the line that I wanted. So that was the side I did want, and we shade the side that we don't want. So that's why this has been shaded green. Finally, my y equals 2x plus 4 was this steep line here. And again, to work out which side of the line to shade, I'm going to choose my origin. So this point here, where x is 0, y is 0. I'm going to substitute those into this point here. So y, so that's 0, is less than 2 times 0, so still 0, add 4. So that's leaving me again with 0 is less than or equal to 4. Is that true? Yes, it is. So again, I can say that is true, which meant that this origin was the right side of the line, meaning I must shade over this side of the line, leaving me just this triangle here that I've marked R as my region.
Okay, I can see that this is a cumulative frequency diagram given to me here. The first thing that I've done is to look at the scale. So the y-axis at the top here, for every 20 squares up, there's one big square, but there are 10 little squares. So what I've done, 20 divided by 10, that means that every one of these little squares is worth 2. Okay, I've done exactly the same for the x-axis as well. And it works out to be the same. So the difference down here is 10, and there are 5 squares. So 10 divided by 5 is 2. So the scale on the bottom, each little square is worth 2. Right, the first question, part A, asks me to estimate the interquartile range. Interquartile means I must take the upper quartile and lower quartile. So, we are told there are 120 telephone calls in total. The lower quartile would be the quarter of that amount. So a quarter of 120 is 30. So we get 30 on our y-axis and we go across till we meet our line. Then we go down. On the x-axis that reads 40 in seconds, 40 seconds. Now it's important you draw these lines across just to show to the examiner that you know where the lower quartile is. The upper quartile then is the 75th percentile, or 3/4 of 120. If you're unsure how to calculate that, remember you have got a calculator with you. So, if 1/4 is 30, to find 3/4 you can either take away 30 from 120 or triple 30 to make 90. So at 90 you go across and you go down. As this cumulative frequency diagram or curve is given to you already and you're not drawing it, the mark scheme actually says it has to be 72. So 72 on here would be the right answer for the upper quartile. So to find the interquartile range, you do the upper quartile, take away the lower quartile, which gives you 32. So for those 2 marks, 1 for showing you doing the upper quartile, take away the lower quartile, and 1 for giving the answer 32. Okay, part B. Calculate an estimate for the percentage of telephone calls that were answered within 50 seconds. I'm going to go across here. 50 seconds. Here. I've gone up to my line where I get 50 seconds. Okay, so I've gone up, straight up. Now I'm going to go across. Okay, what does that read on my y-axis? Well, if I scroll across, I read it to be 45. In the mark scheme it says 44, 45 or 46. So I want to find it as a percentage. I'm going to do 45 out of 120 and times by 100. Remember, you've got a calculator so you can do this fairly straightforward. Then that gives me an answer of 37.5%. Part C, the customer service team was given a target to answer 90% of the telephone calls within 75 seconds. Did the team meet its target? You must show your working and give a reason for your answer. So this bit in here, 90% is really important. So you want to calculate 90% of 120. 90% of 120 in brackets here, the blue bit here, that's how I've calculated it to be 108. So I've done 90 out of 100 times by 120. So I'm going to go across to my cumulative frequency diagram again. At 90 seconds, 90%, I need to see that 108, which is up here, I go across, is that more than 90? It's not. So what you're going to say is, at 75 seconds, only 96 to 98 calls answered, therefore target not met. So if I go across again, so if I'm going to look up this here, 75 seconds is up here, sorry, till you reach your cumulative frequency curve, you go across, that is only roughly 96, 97 or 98 on the y-axis. You need to meet 108, so therefore the target is not being met. Right, what I've done here is I've highlighted the three most important things here. 138 degrees, 3.2 kilometers and 270 degrees. A yacht sails in a bearing of 138 degrees for 3.2 kilometers. The yacht then turns to sail on a bearing of 270 degrees. Calculate the distance the yacht sails in this direction until it's due south of its starting position. So taking all that information into account, what I've done is I've labelled my diagram. So, first thing I did was I know that this angle here is 138 degrees. I know the length of this line is 3.2 kilometers, and I know that the bearing here is 270 degrees. We always start from north when we're measuring bearings, and we always go clockwise. So I know that that's 270 degrees there. As this point here, it says calculate the distance the yacht sails in this direction until it's due south. So once it's due south of the starting point, that means this is directly underneath the north line. So we've got a right angle triangle. When we have a right angle triangle, we know to find a missing side, which we want to do here, either we use Pythagoras or SOHCAHTOA. As we've got an angle here, we're going to use trigonometry or SOHCAHTOA. So what I've done, I've labelled this side, this is the opposite, this is the adjacent, and this is the hypotenuse, the longest side. I've then written out SOHCAHTOA. I've got the opposite. Sorry, I want to find out the opposite, and I've got the hypotenuse. Hence, I'm going to use SOH, so sine. Sine of x, sine of my angle there, is going to be the opposite over hypotenuse. So sine of 42, which is my angle, is x, my missing length, over 3.2. I don't like that 3.2 as a denominator there, so I'm going to get rid of that. I'm going to times both sides by 3.2, so I'm left with that line there. If I put that into my calculator, I will get an answer of 2.1 kilometers.
So standard things that you can expect to come up in either exam, this could come up in the calculator or non-calculator paper, is simultaneous equations. Okay, I'm sure you've seen them before. You may be sat there thinking, I'm not quite sure what to do. Definitely recommend having a research online, looking at Hegarty maths on simultaneous equations if you had nothing for this. Okay, it will come up, I promise you. Okay, so the first question, or the first equation is 5x plus 2y is equal to minus 5, and the second one is 4x plus 3y is equal to 3. You've got to choose whether you want to get the x coefficients the same, coefficient just meaning the number in front of the letter, or the y's the same. I always prefer to get the smallest coefficients, I prefer to get them the same. So what I do is whatever this one here is on the second one, I times the top equation by that, so that times by that, which would mean I do the opposite way around here, so the 2 times is the second one. It would be more than acceptable to get the x's the same, so you would have times this by 4 and this by 5 instead to get x's the same. It doesn't matter which one you do first. When I did my way, I ended up getting tripling everything in this line here, so that gave me 15x plus 6y is equal to minus 15, and this one here gave me 8x plus 6y equals 6. Now, because these values are the same, I need to subtract, but you need to be incredibly careful here. 15x take away 8x, simple enough, is 7x. 6y take away 6y is gone. That's why we did this calculation here. That's the whole point of it. This question here is saying minus 15 take away 6. So my answer must be minus 21. It's very, very easy to accidentally get 9 there. If you get 9, when you try and divide by the 7, you're not going to get a nice answer. You're not going to get a whole number. That might be an indication that you've gone wrong. It may not be, but it might be. Okay? So from here, I've taken the 7 over to divide by 7. Minus 21 divided by 7 gave me minus 3. Now I have my value for x. I substitute it back into one of my 2 original equations. 1 or 2, it doesn't matter which one. Sir has done number 1. I probably would have done number 2 because it hasn't got a minus in the solution, but it does not matter. So subbing that in, that was 5x became 5 lots of minus 3. Add 2y is equal to minus 5. 5 lots of minus 3 gave me minus 15. Plus 2y equals minus 5. That hasn't changed. But now I'm going to take this minus 15 over to the other side and add 15 or add 15 to both sides, whichever way your maths teacher has taught you, which will give an answer of 2y equals 10, hence y is equal to 5. So where your marks came in, 1 for doing this step here, for getting the coefficients the same, 1 for getting what x was, 1 for substituting into the next equation, or into one of the 2 equations, and then 1 for getting y is equal to 5. You should be aware that for part B, that you are going to have 2 bracket answer like that. That's what we should be thinking of when we see this. You need to read between the lines here. The fact that they've given you such nasty numbers here and they want the solution to 2 decimal places and it's on a calculator paper should be screaming at you to use the quadratic formula. Okay? So this is on your second paper or your second page of your paper. Okay? What I do now is I go and add, or I go and say what a, b, and c are. So in your paper, it will say ax squared plus bx plus c is equal to 0. So we need to match up what a is, we need to match up what b is, and we need to match up what c is. So that's what we've done over by here. So a was equal to 5, b was equal to 3, but for c, do not forget the minus bit there. That is the most common misconception with subbing into the quadratic formula. What you need to do now is substitute wherever you see a b, you want to change it to this value here, this 3. So that's a 3 and a 3 go there. Wherever you see an a, we know a is 5, so 5 had to go in there. 4ac means 4 times a times c, so that's why these time signs have appeared. And then c would change to minus 7, so you have to have that minus 7 there, very important. For me, I think it would be worth putting brackets around that statement as well in your calculator. And then 2a, so a was 5, so that's why that 5 has gone back there. Now that doesn't get done in your head, that is calculator time. And your calculator will tell you that answer there. When you put that into your calculator, once you will add that, and once you'll subtract it. When I added it, it gave me a horrible answer, which I pressed SD and rounded it to 2 decimal places, as the question did say, 2 decimal places. And when I subtracted it, I got minus 1.52, which again was rounded to 2 dp.
Right, let's read this question now. We've got a lot of information given to us here. Okay, so I've done a bit of highlighting again. A company produces suitcases with dimensions 55 centimetres, 40 centimetres and 20 centimetres. Okay, the company has been asked to produce a new smaller suitcase. The new suitcase must be similar to the original suitcase with dimensions in the same proportions. The volume of the smaller suitcase should be half the volume of the original suitcase. Find the dimensions of the smaller suitcase, give you dimensions correct to an appropriate degree of accuracy. So we're dealing with different dimensions here. We're dealing with volume and the dimensions, so we're talking about length. What I've done on the side here, which some of your teachers would have used this method before, length, to get from a small shape to a bigger one, you times by the scale factor. For area, to get from the small shape to the big shape in terms of area, you do the scale factor squared. And then for volume, you do small times the scale factor cubed this time. So if we want the volume to be half the volume of the bigger one, that means we're going to have half the scale factor. But the scale factor for the volume is cubed. So to go from big to small, we must do the opposite of cubing. That is to cube root. So that's what I've got here. I've got this little 3 above the square root, which means cube root, and it's 0.5. Why? Because I want half of the volume. So I'm going to times every dimension of my suitcase, and my original suitcase, by the cube root of 0.5. That will give me my new dimensions. So I got 55 times cube root of 0.5 and so on. That gives me 3 solutions here, my new dimensions of the smaller suitcase. Okay. Now it does say here an appropriate degree of accuracy. An appropriate degree of accuracy, if we look back to the top, would be to get it to in similar terms up here, and they're all whole numbers. So what I've done, I've rounded these 3 numbers to the nearest whole number, which gives me 44, 32 and 16, and they are all centimetres.
Okay, and this question was slightly different to the way questions normally come out like this. I'll explain that in a second. It says the probability of Dilys buying a bottle of water is independent. That means it doesn't get affected by the next event. So whatever the probabilities are in the first tree, they stay the same in the second tree. Or they certainly don't get affected by the values in the first tree. It says the probability that Dilys buys an apple and a bottle of water is 0.18. Now normally what they do is they tell you what the values are on the branches. For instance, if you had something like 0.4 there, and then if we said that's R and that's A and that's 0.7, and you'd multiply these 2 numbers to get this value as 0.28. But what they're doing this time is they're not telling you this value here, and they're telling you what the answer is here, but they're not telling you what this value was here. They're saying, what is this value here? Okay, so I know that the probability of her getting an apple is 0.6. I need to multiply that between branches to get the water, and I know that comes to 0.18. So if I take this times by 0.6 over to the other side, I'm going to divide by 0.6, which would give me an answer of 0.13. And if I go back and think about it, 0.6 times 0.3 would give me 0.18. Okay? So when you've got your branches, your first branch there, 0.6 and 0.3, they do times together to give me that 0.18. Okay? We should know that branches on a probability tree add together to give 1. So you think of your number bonds, numbers that add together to give 1 or 10. So 3 add the 7 gives 10, so 0.3 add 0.7 give me 1.0 or 1. On the first one then, 0.6 add 0.4, that would also give me 1. And because it's that independent, that green word there, that meant that these values here would remain exactly the same. Okay, not necessarily the same as this branch here, but certainly these ones here have to remain the same. That's what independent means. For the second question, it says, what is the probability that she does not buy an apple and she does not buy water? Well, she doesn't buy an apple here, and she doesn't buy a bottle of water here. So it's that 0.4 times 0.7. It's a bit of a coincidence, I just did that calculation. 0.4 times 0.7 gives me an answer of 0.28. Okay, this is a question on circle theorems. Circle theorems are notoriously hard. People find them very, very, very difficult to understand. I would recommend going to this guy's website, Hegarty Maths. He's got an amazing video that takes you through all of the circle theorems. Okay, so this first one, if you notice here, you have got a 4-sided shape here, and its corners or its vertices are on a circle. Now that has got a name, that is called a cyclic or a cyclic quadrilateral. So when these 4 points are on a circle, it tells me that the opposite angles add together to make 180. So those two make 180, these two make 180. I'm not interested in these two though, I'm only interested in these two. So I want to do 180 subtract the 125 to get 55. So I know that A is 55 degrees. The other rule that you've got to know is that this shape here, the angle at the circumference is half as big as the angle at the centre. Now that means this angle is twice as big as this angle. We know what this angle is. We just worked out this is 55, so this must be twice as much, which is 110. So A and B are 110. For part 2, it asks for a reason as well. We have a tangent meeting a triangle. When a tangent meets a triangle, this angle here is the same as this angle here, and this angle, let's try doing that one, this angle here is the same as this angle here. So that means that angle C must be the same as 85, and the reason why that is due to something called the alternate segment theorem.
So looking at the information given to us down here, D is a point on the side BC, ABC is 35 degrees, ACB is 60 degrees. Those little hats above the B and above the C, that is where the angle is going to be. So it's going to be ABC, the middle angle, so here is 35 degrees, the middle angle of C is here, that's 60 degrees. AC is 10.6 centimetres and BD is 14.2. And what the question is actually asking you to do is to calculate the length of AD. D is a point on this line, okay? So what I've done in yellow here is just place D anywhere. I don't know how far across it is. I want to find the length from here to here. So I've labelled everything I have already on my triangle, and the first thing I've noticed is I don't know what AB is. I don't know this length here. So what I'm going to use is the sine rule, as I've got a side here, okay, and I want to find out another side here. I got a side here and its opposite angle, okay, another side here and its opposite angle. So sine rule is B over sine B and sine over sine C. You've also got A over sine A as well, but you only choose two of them, the two that you want. So I've labelled up here my triangle. The side that's opposite the angle C we call little c. The side that's opposite the angle big B we call little b. So we're going to use those. So here we've got 10.6 over sine 35 equals AB, which is my missing length, which I want to find first of all, over sine 60. We don't like sine 60 down there, so what we're going to do, we're going to bring it up and multiply the left hand side by it, or both sides by it, but it gets rid of this sine 60 down here. If you put that into your calculator, you will get the side or length of AB to be 16.0046 centimetres. Now you know this side, okay, you want to find out ultimately this side here, AD. So we're going to treat it as a different angle now. That's why I've drawn this red dotted line down here. We've got the length AB and we've got BD. We've also got an angle in between. That means we must use the cosine rule. So, like I said before, the cosine rule is at the front of your formula book, of your paper, sorry. That is going to be this here. B squared is equal to A squared plus C squared minus 2AC cos B. AD is what we want to find out. That is B up here, okay? That's what we're calling that line there. So I've computed, I put everything in I know, 14.2 squared, which is A, 16 squared, which is C, minus 2 lots. I would recommend that you put in, when you're putting this into your calculator, that you put in brackets here, okay? 2 lots of all that, 14.2, 16, and cos 35. Once you've done that, you'll get AD squared is equal to 85.4576. Then you're going to square root that answer. That will give you 9.2443 centimetres. On the mark scheme it says rounded or truncated. So if you had 9.2, 9.24, you'd still get the full 7 marks. Right, what I've done, I've split this down here. I want to find out 4.6, I've been told, is the radius. 93 degrees is that angle. I want to find the area of this shaded region by here. So what I've done here is I've just made it just a bit simpler really. I've taken the sector, I'm going to take away the area of the triangle here, which will give you my shaded section. Sorry. If you're going to have that method in your answer, that's just a mark straight away without doing any maths. For realising that you're doing the sector, take away the triangle to get that shaded region, you will get a mark. Okay? So, area of a sector, unfortunately, it won't be on your paper. You'll have to learn it, so it's a need to know. That is pi r squared, where r is a radius, times theta, where theta is the angle. So in this case, it's 93 degrees divided by 360. It's basically like finding the area of a circle, but a fraction of it. So whatever your angle is out of 360, because a full turn is 360 degrees. So if you compute that in your calculator, so you're putting in 4.6 for the radius, 93 for the angle, that will give you 17.17 centimeters squared as its area. The second part then is to find the area of the triangle. You find the area of a triangle by doing half AB sine C. This is at the front of your paper, so you will be able to see that. You don't have to remember it. So you can have half A times B times sine of your angle. A and B, if we look up to our triangle here, A and B are these two lines here. They're both 4.6, they're both the radius. So it's going to be half times 4.6 times 4.6 times sine of our angle, which is 93 degrees. That gives us 10.5655 and so on. Okay. Now we just need to take the area of the sector, take away the area of the triangle, which leaves me with 6.6 centimeters squared. Now in the mark scheme they say approximately, so if you've rounded up here, okay, and here, you might get a slightly different answer there. So there's a bit of leniency in the mark scheme.